So my claim to fame in this regard is that I'm old enough to have attended some of the Cold Spring Harbor symposia of note. The ones where phage and bacterial genetics were being made in front of us. I was there at the interface between what Bill attributes to Gunther Stent having been the Romantic period and the dogmatic period. I attended the Cold Spring Harbor Symposia in 1953 and 54, and then I got to give a talk some years later there. The symposia were extraordinarily influential. They went along with the phage course, which had started earlier in 1945, and of course the phage meetings, which were not held there mainly. But I would like to relate just a little bit about the atmosphere of the place. So this is a totally personal little chat, not to be confused with science. Okay. Going there as a graduate student was a life-changing experience. I mean, it was really dramatic to be in the presence of these luminaries who were creating a new science. Molecular biology, as we know it, started sometime during the Second World War. It matured in the Romantic period, which was the first decade of it, ending around 1953 or thereabouts. Going to these meetings was being totally immersed in the sense that something was being created, something new was happening. And by the way, I personally do not make the distinction between phage and bacterial genetics, because to me it was one thing. To the phage people, this is heresy here. but to me it was one thing, because the people who were studying these things were talking the same language and talking to each other. So, and in fact, they went back and forth. They used the tools that were developed by one were totally used to the other. So I think this was not the distinction that Forrest would like to see. Okay, what is Forrest? Anyhow, so the other thing that I would like to comment on is that this was a time where there were a lot of low-hanging fruits for the picking. The tools had been developed, or the ability to ask questions had developed. It was more a mindset than a technical development. The mindset was, yes, we can answer questions, and we might as well ask important questions. So it became a sort of almost a game to figure out which of these fruits are worth eating, which of these fruits are worth picking. And this is why I think the Delbruck statement came up, because there was a lot of there were a lot of people who got into the business and said, yes, I recognize there's a revolution going on. I'd like to be part of this revolution, and I'm going to decide what's important. And a lot of this was not successful. So what Delbruck was talking about was the fact that there were a lot of people doing work which wasn't worth doing. I like another quote from Luria, which is very analogous to this. Luria said, if something is not worth doing, it's not worth doing well. Which I think expresses the feeling that a lot of things which were being done were not worth doing. So you had sort of a natural selection of what was important and what wasn't. I think that they weren't always right. For instance, from my own experience, I was involved in some work which involved whole cultures, whole cells, dealing with the idea of a cell rather than a molecule. And this was, no, this was not the way to look at it. So when I gave a talk at Cold Spring Harbor, there were no questions. Well, this was not in the spirit of Cold Spring Harbor, but everybody asked questions all the time. So whoever was the convener turned to Luria and says, come on, say something, Salva. And Salva said, interesting system. I got to tell you, there's nothing more insulting to a scientist than to be told he works on an interesting system. That's the ultimate in insult. Anyhow, the reason was that the Copenhagen School of Bacterial Physiology I I was nurtured in, was not dealing with questions which were approachable at the time on a molecular level. Therefore, they didn't count. So not everything about the selection of what's of general importance was correct. Far from. But it was good enough to create a whole new science. So what was it like to be there? Well, it was really amazingly collegial in the sense that everybody told everybody else what they were doing. This idea of sending material to Delbruck for criticism, for permission, was ingrained sufficiently that everybody sent out what was called preprints in those days, which were one simply mimeographed. Does anybody here know what a mimeograph machine is? Very good. And this was a way of duplicating things. Instead of using carbon paper, there's a good one, that was using typewriters. Anyhow, instead of using carbon paper, you could only make about 5 or 6 copies. In a mimeograph machine, you could make a couple of dozen. So you mimeographed, you made copies of your paper, and you send it out to all your friends. And whoever was on the list was recognized as being part of the group. So the idea was you tell everybody what you're doing. The sense that you should be careful and not tell because they may steal your ideas from you did not exist. For one thing, all the protagonists of this game thought of themselves as being so smart that nobody else is going to outdo them. So there was no danger of your competitors outdoing you because I'm smarter than they are. So there was a lot of hubris, and the hubris worked beautifully. It really worked beautifully. So, but there was a certain harshness, and the harshness is demonstrated in the fact that some people were judges of what was worth and what is not worth doing. So I have to tell you, however, that there was another factor which has not been mentioned, and namely that all this was done under conditions of extraordinary social benevolence, manifested by the fact there was plenty of money. So it hurts me beyond words to talk about this because I know what the situation is like today. And it's painful to tell you that money was there for the asking. I'll tell you a little story. I went to Tufts University as my second job. I had tenure in my previous job at the University of Florida. And when I went to Tufts, it did not occur to me to ask if I was going to have tenure. I didn't ask because it didn't matter. Okay, those were those times. So there was a period of time, about 10 years. It ended. It ended with Nixon. And when that happened, money was not quite as available, but for a period of time, it was literally there for the asking. So that this idea that you're competing for a grant didn't exist. You simply got it. And I think that helped. It can't but have helped. If you don't have to think about the source of funding, you've got time to think about your science. And so those were the days. So I'd like to show you a couple of slides of what it was like. How do I do this? What do I push? Oh, okay, thank you. Okay, this is what Cold Spring Harbor. This is what Cold Spring Harbor looks like in the fall. Beautiful New England scenery. These are the buildings are all over the place. It's on the north shore of Long Island. It's about an hour from New York City, depending on how you get there. Sometimes it's much more, sometimes it's less. Anyhow, it's a beautiful place, and in the summertime, it's just gorgeous on the water. And you can see this magnificent setting, which just was inspiring. And it was secluded. Not all the buildings were new. In fact, there was this nice sort of old-fashionedness to the feeling of Cold Spring Harbor. You were there in a sort of like an old northeastern town that had this characteristics. And these are some of the people. Some of them have been mentioned already. Some have not. One of the great heroes of the piece is Miroslav Demerej, who was the director of Cold Spring Harbor at the time when the Phage course started. You saw a quote from him. Bill showed a quote about what he had in mind. He was the guy who really made it possible to have a place, a central place where everybody came once a year. And by coming together once a year, this made a significant difference in the way people interacted and coordinated. Rollin Hodgkins is one of my personal heroes. He's the guy who really did the experiment that showed the transforming principle was DNA. Until then it was thought to be DNA, he showed it. And he was just a magnificent guy who sat on the front row at Cold Spring Harbor and made snide remarks which were extraordinarily funny. So he did this all day long. Salvador Luria and Delbruck, of course, have been mentioned. And then there is people like Martha Chase, which you mentioned her, and Al Hershey. And Einstein, not Einstein wasn't there, but Szilard was. Let me tell you something about Leo Szilard. He was the freelance of science in the sense that he had been a physicist of great note. And the reason he's in this picture is because he's the person who went to Einstein and says, "Dear Albert, you have to write that letter to Roosevelt that says, yes, we can make that bomb." So he was the person who started the process that ended up in the Manhattan process. Like many physicists after the war, they didn't want to work on the bomb, so they turned biologists. But the way he turned biologists was unique. He had no lab, but he would travel. He was at the university. He was based at the University of Chicago, but that didn't matter to him. He just traveled all over the world and told people what to do. He would go into your lab and says, "This is what you should be doing." And he did it with aplomb, and it was really wonderful. But he was a very scary person, and I can tell you the experience I had of getting my lunch on a tray. Lunch at Cold Spring Harbor consists of getting a tray full of stuff and putting it and going out of doors and eating on a bench. And I'm sitting there, I put my tray down, and who comes and sits next to me? But Leo Szilard. Oh my God. So I'm already shaking, and he turns to me and says, "Well, young man, are you doing something important?" Okay, so anyhow, I had that experience, and it stays with me. There is Jim Watson. I was there in 1953. Watson had just come back from England, from Cambridge, and this is the first place where he announced the structure of DNA at Cold Spring Harbor, at the meeting in Cold Spring Harbor in 1953. And to my eternal shame, I didn't get it. I said, "So it's a double helix." Well, it takes people a little bit longer than others. And this is you saw this picture already. It shows some of the notables there. And then I want to show you a connection between San Diego and Cold Spring Harbor. This is Stanley Malloy, Dean of Sciences here, who was involved with the ASM awarding a plaque that denotes that the place is a milestone in the development of microbiology. So at Cold Spring Harbor, there is such a plaque. I think it's being unveiled here, and this is Watson standing there pontificating on. There is another connection, namely that the course in bacterial genetics has been taught by several people from San Diego, and here they are, our own Kit Pugliano and Anka Segal and Stanley Malloy. So thank you.
Elio, what did you say when he asked you?
I thought I belonged underground. I should disappear. Actually, I was not doing something important. I had a miserable time doing my PhD thesis. It was crap. So, what am I going to say to Szilard? He didn't want an answer. It was the question that mattered rather than the answer. It was a Talmudic question.
I was raised in the same scientific tradition that Moselio was in the Copenhagen School, what we called quantitative biology at the time. And the odd thing was that the Cold Spring Harbor phage genetics types completely rejected the quantitative approaches of Ole Molding, Kjelgaard, and so on. And so I was shocked when I got into phage biology a little bit later. Not late to most of you, but compared to Alan Campbell, I got in about 1975. But I had come from what I thought was quantitative biology, and it was completely, and yet the Cold Spring Harbor Symposium was called
Yes.
quantitative biology,
Yeah,
totally
right.
qualitative.
It seems
Bill?
like one of you should mention François' ending questions to every talk.
So, okay, the quote exactly is, so what's this all about, right? Isn't that what he's,
What's the take-home
yeah,
message?
what's the message, right? Yeah. Bill?
I would say that perhaps Einstein and Szilard were not talking about the letter to Roosevelt, but they were the co-holders of the patent on the refrigerator. They made a lot of money from General Motors. Every year, apparently, they had a meeting in New York to divvy up the
Very good.
royalties.
Well, you never know.
There's more to physics than quantum mechanics.
Yes, Mia.
So I know, I mean, a lot obviously came out of the phage group focusing on the T-phage and all kind of working on the same thing and this narrow view of what people should be working on, so then we did make a lot of progress. But my knee-jerk reaction, I'm sure this is because I was scientifically trained by Forrest, who doesn't like being told what to do, is that, you know, we shouldn't be told what to do because we might be ignoring all these other interesting phage and interesting problems. So, you know, what was your guys' feeling about that coming out of sort of a different school that was not doing the accepted stuff?
Well, first of all, I was in awe. Okay, it's very difficult to argue when you're adoring somebody and you say they're the holders of all truths. So I was cowed by these people, okay, personally. And that has had an influence. But other than that, I thought, well, let me tell you what happened to the person, since we're getting personal. After doing the work in Copenhagen, my boss, 06Moselio, said, you're going to England? Go see my friend Francis Crick. So I go to Cambridge, knock on his door, and he lets me in, and I tell him what we did. And he says the following. He says, congratulations, you started a new field, but it's over. Going from inception to oblivion in one step. Well, I thought he was right for the time, but I had the hope that this was simply that he was anticipating, he was talking about the moment and not about the future. And it turned out that he was wrong, because what's called systems biology seems to be based on just this kind of quantitative science. And it's coming up. I mean, frankly, what's happening is people are writing papers that mention this work, and they come to me and say, you mean you're still alive? So you have to have your moments. You have to have your moments. By the way, for the young people, this illustrates something. There's a paradox. I mean, everybody who's young here wants to be famous, right? Okay. By the way, my recipe for being famous is very simple. Change your name to Eppendorf. But because nothing else will work, here is a paradox. The more important and the more central your work is in the context of the day, the less it's going to be, your name is going to be quoted. It becomes, what you've done is become parts of what everybody knows, parts of the ethos of the time, and you're forgotten. You don't remember who discovered that water is H2O. It was Lavoisier, but who cares? You don't quote Lavoisier. That's what happens with important stuff. If you do work which you don't know at the time, but may turn out to be anticipatory, then your name reappears. It's a strange paradox.
Didn't he get his head cut off?
Yeah, Lavoisier, I think so. Yeah, the revolution doesn't need chemists. So, you know, this is a strange paradox. The more important the work you're doing, the less lasting your fame. So forget about fame. Have fun.